Hello everyone. In today's video we're going to talk about Physics 253 Week 5 problem number 25.3. In this problem you're tasked with finding the speed of an electron that is released from a negative plate given the speed of a proton that is released from a positive plate in a parallel plate capacitor. So starting off with this problem, we aren't given too much initially. You can kind of see that we have our velocity here, and we have various identities about the plates and what we're releasing, which is helpful because we're going to need those. We're going to need all we can get in this problem, and for this problem, I went ahead and started off by drawing a little drawing here. So we have our parallel plate capacitor here. We have general force from the positive side going this way. Here we have our electric field, and this is kind of propagating the electrons and protons, or the charges, along to the right. And then we have the force from either side of the plates affecting the charge, or affecting the motion of the charge as they propagate to the right. So here, this is our first case right here. Here we have our proton, and our proton is traveling to the right, and it starts to become attracted to the negative and repelled by the positive. So it lands at the speed here. We can do the same thing with this, our negative charge, our electron here, and we can just kind of send it off of the negative plate from rest, and it's going to travel and hit the positive plate at some point, and we're solving for the final velocity. So for this problem, what we have is we have velocity, and we have mass, and we have charge. So we can kind of manipulate these by using energy, specifically electric potential and kinetic energy, and we can solve this problem. So since we're working with a closed system in our parallel plate capacitor, we can say that energy is conserved, and we're going to have our electric potential energy is going to equal our kinetic energy. So when we do this, we can define it as having two different properties. So we can say that that our charge multiplied by our electric potential is equal to our kinetic energy for our protons here, P, and we can do the same thing for our electrons here, E. So that we can just kind of set our two kinetic energies equal to one another. So when we do this here, we are able to rearrange the equation, because what we are looking for is this velocity here. So after we rearrange, we take the square root, and we are given this equation here. From here, all we have to use is our mass of a proton, mass of electron, and just plug in. So we have our velocity, our two values, and we are left with 2.14 times 10 to the 6 meters per second as the final velocity for our electron that lands on our positive plate from the negative plate. So thank you very much for watching. I hope you guys enjoyed this video, and have a great rest of your week.